Welcome to Practical VLANning 101. This presentation focuses on the practical implementation of virtual local area networks in small business environments. The format is simple: a note about me, followed by a quick 5-minute review of VLANs. Then we will talk about implementation. My career in IT started in tech support and computer repair. I was a system administrator for a property management firm with dozens of locations. I moved to work as a network engineer for an internet service provider and was responsible for bringing new internet service to hundreds of thousands of homes and businesses. I then entered the field of network security. I worked for a popular DDoS mitigation firm and was responsible for network configuration and BGP rerouting of traffic. I presently work for an IT consulting firm as a solutions architect. In Cisco networking class, it's common to be shown something like this, right out of 1989. Most commonly, VLANs are presented with descriptions such as sales, accounting, engineering, and guests. This scenario usually relates to something to do with creating an access control list such that employees in the engineering department cannot access the payroll database server in the accounting department, and tasks you with providing a properly written example of implementing an ACO or access control list to block traffic between the VLANs. What interface do you place the rule on? Do you place it as an inbound or as an outbound rule on that interface? And that's generally about as far as it goes. As you realize immediately upon entering the real world, this is not a realistic example of how VLANs are used even in a small business network. Sure, blocking traffic between devices that shouldn't be talking is a large part of what we use VLANs for. However, even in a small business, and certainly in larger organizations, you'll quickly realize there are other uses for VLANs, and sometimes their implementation can be kind of tricky. VLANs are a means of dividing network traffic into separate virtual networks. Network switches are the primary means by which traffic is identified. A port on a managed switch can be configured as either access or trunk. By configuring a port as an access port, the connected devices will be unaware they are in a VLAN and do not need to have any special configuration. The switch will add a tag or VLAN tag to each packet received via that port before forwarding the packet. Ports configured as trunk have a default VLAN, but in order to send data to other VLANs, the connected device must tag the packet with the ID of the destination VLAN. Generally, each VLAN will use a different subnet from each other VLAN and subnet on the network. For traffic on one VLAN to reach a destination on another VLAN or subnet, a router will have to decide if that packet can be routed to that network based on the rules configured in the router. Separating devices into virtual independent networks, or VLANs, can be used to increase security and network performance by having better control of what devices can communicate with what other devices. Capable wireless access points can broadcast multiple SSIDs or wireless networks. Each SSID can represent access to a particular VLAN. The access point can tag the traffic it receives over a particular SSID with the appropriate VLAN ID. There are security implications to having a device which can tag its own traffic on multiple VLANs. However, for most small business needs, the benefits greatly outweigh the risks. Devices such as voice-over IP phones can be identified by the network switch using a technology called Auto Voice VLAN, or LLDP MED, Link Layer Discovery Protocol Media Endpoint Discovery. While the phone is connected to an access port, the default VLAN of that port can be passed through to the computer port on the phone. The phone can add its own VLAN tag to the traffic originating from the phone, so it can communicate on the VLAN designated for voice-over IP traffic. This can enable use of a single Ethernet drop to connect both a phone and computer on separate VLANs. While popular, there are arguably drawbacks to this implementation from both a security and performance perspective. Now, with that quick review out of the way, let's get into the first scenario. You are hired to work as a consultant for a small professional office. The office network consists mainly of the following: 20 computers, 20 phones, one file storage server, one music streaming device for background music, 4 printers, and a camera system. Most devices are to be hardwired. However, the business wants wireless for employees, visitors, IoT devices, and other internal network equipment. Up until now, everything has been plugged into a consumer-grade Wi-Fi router with multiple inexpensive Ethernet switches daisy-chained together. The business owner complains, the calls break up, the background music starts and stops, and things are slow. You discover the neighbors are using the guest Wi-Fi to run their entire office for free, and various employees are using a lot of bandwidth for non-work related purposes. So you decide to start off by implementing a business-grade router. Not the sort of thing they sell at a local retail store, but something more suited for business use. Perhaps you implement a server running pfSense, or something a bit more approachable, such as offerings from Ubiquiti or Cisco Meraki. One of the first things you'll want to do is start separating the network into VLANs. What should you make for VLANs? What devices should go in what VLAN? First, you'll want a management VLAN. This is the default untagged VLAN. It's where you'll assign IP addresses to network devices, such as a managed switch, and wireless access points. It's okay to use the default VLAN of 1. The perspective we are looking at today is getting started without getting overly complicated. Next, you'll want to put all the voice over IP phones into their own VLAN and all the PCs into another VLAN. Already the situation is improved. Although quality of service tagging can help, it's easy to specify priority and reserve bandwidth for the voice over IP VLAN over the PC workstation VLAN. Also, the computers and the phones don't need to talk to each other, so now there is some separation. This might surprise you. Single device VLANs. Yes, it's okay to make a VLAN for one single device. I do it all the time. A good example is the camera system. Incoming traffic from the internet needs to be forwarded to the recorder so the cameras can be accessed from off-site. Placing the recorder in its own VLAN allows that device to receive traffic, but inter-VLAN routing rules can block the recorder from trying to talk to other devices on the LAN in the case that the recorder is compromised. Some recorders already have support for 2 separate networks built in. Some have 2 Ethernet ports. One connects to the main network for user access to the recorder, while the other port is specifically for the cameras. The main network can't see the cameras through the recorder, as it does not provide routing between the interfaces. So therefore, the recorder on its own LAN port becomes a single device VLAN. Other recorders have a built-in power over Ethernet switch with ports equaling the number of cameras supported and keeps this network separate from the LAN interface that the recorder communicates to the LAN with. For recorders without this functionality, a managed PoE switch can be used to keep the traffic isolated, while the router can be configured to only allow traffic from the recorder to the LAN/internet. Another place VLANs are very helpful is with wireless networks. Not all devices that need to be on a wireless network should be able to talk to each other or other devices on the LAN. In this office, 3 separate wireless networks were configured. The owner Wi-Fi network, with its own assigned VLAN, may have permission to communicate between VLANs with the camera system, but the VLAN can be blocked from initiating communication with other VLANs. The employee Wi-Fi network with yet a different assigned VLAN may not have permission to communicate with the camera system, which stops employees from figuring out the owner's simple password or using tools or master passwords found on the internet and deleting footage of their wrongdoings. The guest Wi-Fi network will naturally have the lowest per user bandwidth, and the network as a whole can be limited to however much bandwidth you want to budget for guest use. This also makes it easier to apply traffic restrictions in the router to the guest network because it is a separate network. With different VLANs, it's easy to set bandwidth limitations. For example, on the employee VLAN, each employee can have a specified maximum upload and download rate. The VLAN as a whole can have a maximum rate. This is great for making sure that employee Facebook traffic doesn't overwhelm the available bandwidth of the internet connection, while still allowing employees to have internet access on their personal devices. Per-user bandwidth restrictions ensure that one individual cannot monopolize the bandwidth, while per-VLAN bandwidth restrictions ensure that the VLAN as a whole cannot monopolize the internet connection. By placing the background music appliance in its own VLAN, it is easy to ensure it gets enough bandwidth to not have any interruptions in the music. You can reserve bandwidth for that device. You can also control who has access to that device and its settings. VLANs can help you allow external inbound connections to devices while helping to reduce the chances that if the device is compromised, that it will not be used as a door to the rest of the network. VLANs can also help you ensure that everyone gets a fair slice of the available bandwidth pie. VLANs can also be used to make sure both employees and guests cannot access devices they should not have access to. It is very common that after the network install is complete, the customer goes shopping. They purchase IoT and other insecure consumer products and connect these toys to their network. Some IoT devices require inbound traffic to be allowed, which leaves these devices easily compromised, either directly or via automated bots scanning the internet for their presence. They can also malfunction, flooding the broadcast domain or causing inadvertent ARP poisoning by falsely identifying itself as a different device, such as the default gateway. Choosing something non-standard for the management and main office LAN helps obfuscate. It's easy to sit there and try to look for things on 192.168.1, 10.0.0, 10.1.10. This also causes problems with VPN configuration, where the remote user may be on a network using one of those subnets already. So it is helpful to use non-standard IP blocks such as 192.168.40.x to reduce the chances of that occurring. VLAN ID numbers are how the network identifies what data is associated with which VLAN. While you can use any valid numbers supported by the equipment you are using, it's easiest to have VLAN ID numbers match some part of the subnet. For example, 192.168.40 with a VLAN ID of 40. It's best to use random numbers to help obfuscate so would-be attackers can't try to tag their packets with common numbers. But for a small office and the technician installing the network, the added complication can be a bit unnecessary. It's going to make things much more confusing when trying to troubleshoot. Another reason why proper documentation of your network implementation is absolutely critical. This office has a Windows server. This server is basically used as network attached storage. Employees save files onto the network share, and other employees can access those files. In this business, all employees have access to the file server and all use the same password to do so. While it's perfectly fine for all employees' desktop computers to be on the same VLAN, this office should use Active Directory and have individual user accounts for each employee. This would enable a AAA model: authentication, authorization, and accounting. Workers are able to see contracts and other business information shared between sales and management staff. A disgruntled employee could easily delete all the files on the network share and cause a large amount of grief for their employer. Sometimes you're going to work with a client that isn't interested in investing in their IT infrastructure. I find that small changes over a long period of time work best in these situations. As a matter of fact, it can be a very effective strategy of bringing a company up to speed. This organization is now at least able to use VLANs to separate their voice over IP traffic, their work computers and server, and their guest Wi-Fi into 3 separate virtual networks. While improving security and reliability in a small business network certainly doesn't end with VLANs, remember, prior to VLAN implementation on this network, even a guest on the guest Wi-Fi had full access to all the company's data. VLANs are a critical step towards improving security. It's important to take into account the kinds of devices the business uses and the way the business operates. Not all businesses have the same social and authority structure. Some businesses have a small group of dedicated employees and expect most of them to spend their entire careers there, while other businesses have a high turnover rate of low-paid workers. The spectrum is wide, and I encourage you to take the time to get to know the business and the way the employees interact not only with their superiors, but with business technology as well. Second scenario. The second scenario is a restaurant and bar. The restaurant has the following equipment: 8 point-of-sale stations with serial attached receipt printers, 3 voice over IP phones, 4 Ethernet-based kitchen station ticket printers, a camera system, a music streaming appliance, 5 to 10 IoT devices that control lighting, temperature, TV channels, etc., and a back office server. You'll find that even though we've gone from an office environment to a bar and restaurant, much of the underlying principles of network implementation are the same. In this network, instead of desktop workstations, we have point of sale or POS stations. A POS station is really just a computer that's generally used only for the purpose of running one program by its user. This program manages open tickets, ensures information reaches the correct staff member for each item of food and drink to be prepared, generally via a kitchen display system or paper ticket printers at each station in the kitchen, as well as accepting payments. While the users generally only interact with the POS software, in most cases there are several programs running in the background on these systems. Normally, the POS stations would go into a different VLAN from the back office server. This would allow me to limit the communications exclusively between the point of sale station and the back office server without any independent access to the internet. In this scenario, the POS stations are remotely managed by the POS vendor, and they use several internet-based services. While I could itemize these services and implement policies, it's easier and more practical to simply place them all on the same VLAN, including the POS back office server. This enables the POS vendor to use different services, such as changing the remote access vendor, without resulting in a service call from me to reconfigure the network and firewall rules to allow it, possibly blocking them from providing support to the customer in the meantime. So in this network, the POS stations and the POS server are on the same VLAN. I can use this to write firewall rules to allow traffic to the internet. Again, well, if I was providing the POS system, I could write more secure rules to only allow the specific necessary traffic. Due to the nature of working with an outside vendor and the needs of the organization, I find it perfectly acceptable to allow them communication with the internet. Security can be improved by implementing some rules at the router or firewall level to help block malicious traffic. Some port forwarding allows traffic from the internet to the POS stations to allow the vendor's remote support to work. This vendor maintains that they have a full live backup of all the data and can easily re-image all the machines and server in the event of a security breach. This network has other concerns as well. They have wireless point of sale stations that the staff can walk around with. Their wireless network supports multiple SSIDs, and I make use of that to have a dedicated SSID for the wireless POS equipment. Devices connecting to this network can have their packets tagged with the POS VLAN ID automatically by the access point. One point for security is that no SSID should be untagged. This helps to avoid making it all too easy for someone to tag their traffic for a different VLAN and hop over should they be able to access the wireless network for an untagged VLAN. Also, the access points are only permitted traffic on the specific VLANs necessary for the different SSIDs. In a bar or restaurant, music may not necessarily be considered background, but a critical part of the ambiance. Music streaming services can include both a dedicated device as well as the required copyright performance licenses and ease for the bar owner to ensure the right kind of music is played at the right time for the ambiance they are trying to create. In these establishments, this device is considered critical. This device is placed on its own VLAN. This allows that VLAN to have reserved bandwidth, no unnecessary packets in its broadcast domain, and a priority level second only to the voice over IP phones. This ensures the music flows smoothly without interruptions. But what about phone calls flowing smoothly without interruptions and breaking up while customers are trying to place an order? Voice over IP traffic is separated on the voice over IP VLAN. Bandwidth is reserved and this traffic is prioritized above all other traffic, and this ensures the lowest possible latency and jitter for clear phone calls. If a customer has to repeat their order, it's because their cell phone is breaking up, not a poorly implemented voice over IP installation. On this network, multiple SSIDs are critical. Per user and per subnet bandwidth restrictions are critical to this network functioning. With only 50 megabits down and 15 megabits up of bandwidth, there can be 250 users on the guest Wi-Fi, multiple voice over IP calls for to-go orders, entertaining music, and of course, credit card transactions. Without VLANs and the features they enable, this simply would not be possible. We live in an era of inexpensive offshore-made novelties. Business owners and employees are all too eager to connect these devices to their network, oblivious to the security implications, the consequences, and the likelihood of those consequences, as well as the downtime and flat-out cost of recovering from being hacked, or even just a well-meaning but malfunctioning device. VLANs can help separate the network to reduce the impact. Implementing VLANs is by no means a solution in itself. However, it is a massive step in the right direction. Both security and performance start with separating the network into VLANs, as this opens up a world of possibilities, from traffic shaping to improve performance, to routing policies to start improving security. Thank you so much for listening to my talk. If you'd like to reach out, here are some ways to do that. I'll also be available on Discord.